Hello. The world is changing. The cloud has become the de facto new standard for doing IT. The attackers still want the same things, but their methods and tools constantly change and evolve to the new environments. We cannot keep up using the same old methodologies and same old techniques in order to meet those new challenges. My name is Roy Feintuch. I'm doing cloud security since 2010. That's a long time ago. That's when AWS launched the VPC. That's where Dynamo, or sorry, that's where SimpleDB was the new hotness. That's where they created the tags for AWS instances. Since then, I've been co-founding Domain Security, which started a new category, CSPM, Cloud Security Posture Management. And for the last 2 years, I've been working at Checkpoint as the Chief Technologist for Cloud. I still work a lot of hours and love my job. So in this session, we're going to go really deep into what does a cloud-native attack look like from the inside, and really how to help us protect ourselves. In order to achieve that, I'm inviting my colleague Maya Horowitz, which leads Checkpoint Threat Research.
Hi everyone. So I'm Maya, and today I'll be your hacker. So today my mission is to steal Roy's data and his money, but on a day-to-day basis, Checkpoint Research is more about white hat hacking. So we look for the threats that are out there in order to make sure that our different cybersecurity products can cope with any state-of-the-art attack that is out there. But also we look for new vulnerabilities and work with the relevant vendors in order to close the gap and make the world a safer place. But today I will be doing the first drill, trying to hack into Roy's environment. Now, on a day-to-day basis, for us hackers, going and targeting a cloud environment is just like targeting any other environment, actually. As you can see here from the MITRE ATT&CK framework, the tactics are not that different, but the techniques actually are. And the reason is that now the cloud has become our operating system. So we need to look for cloud-specific features and flows that we can manipulate in our attacks. And that's exactly what we'll be doing today.
So, the theme for this session is going to be pretty simple. Red versus blue. Maya is going to try to attack my environment while I'm going to try to protect it. So game on. Our environment. My environment is a pretty simple one. It's a serverless application, consists of an API gateway that in the front, then the Lambda function, a Lambda function that is serving the main business logic, while the persistency layer is a MongoDB, a self-hosted MongoDB with an EBS backed by EBS volume. Now it's a pretty common setup. MongoDB is a very popular database, and self-hosting it's also a popular approach. While on the front side we've got the more serverless, modern serverless approach with Lambda and API gateway. As you can see, from outside perspective, or from Maya's perspective, the only thing she can see right now is the front of my application, which is just an API gateway serving my API. So let's see what Maya can do with it.
So indeed, for now, all I can see externally from Roy's environment is his API gateway. But I can see some of the API gateway calls that seem like they're hitting some Lambda functions. Now, after some trial and error, I understand that at least one of these Lambda functions is actually susceptible to potential LFI attacks. So LFI, local file inclusion, just means that one of Roy's programmers actually did a mistake in the code and he's looking for some input without doing the right validation on it. And this is exactly what I will be exploiting in the first stages of the attack. So now, using curl from my own machine, I will try to run some command that is using a fake product name, but it's actually a specific product name that will let me extract the process's environment variables. And you can see that it gives me access to the token ID, the secret, and some additional variables that might be relevant in the next stages of the attack. So for now, you can see that all I have access to is my own credentials. Okay, from the hacker account, I only have my own credentials. But now I will actually attach the environment variables that I was able to find into a new token that I will call stolen lambda. And now it means that with the stolen lambda, now that I have the token ID and the secret of the original lambda, I can actually use it to impersonate the original lambda at least for the next 15 minutes. So you can see through get caller identity that now I actually look exactly like the original lambda. What I will also do is just to export the victim account ID. It also might be useful in the next stages of the attack. Okay, so what I have so far is just a small chink in the armor. It's not like I'm able to do remote code execution or anything that severe. But I do have this stolen lambda profile that I can now start using to see where it can lead me. So I'll continue soon. For now, Roy, I'll give you a chance to catch up with what I've done so far.
Very well. So Maya got some access to my environment through an application vulnerability on my side. So let's see how we can protect against that. So our first preventative measure that we'll deploy is a WAF, Web Application Firewall. Thankfully, AWS has provided a simple-to-use WAF service that is very, very nicely integrated with the cloud platform. So whether I'm hosting my app or my gateway is an API gateway or an ALB, Application Load Balancer, or CloudFront, it's a very trivial integration with those tools. So AWS WAF serves as our first line of defense. It's usually pretty basic and signature-based, but still it can protect us from common application exploits like OS top 10, SQL injection, LFI like in this case, and so forth. But then you might be asking, hey, I've got dozens, hundreds of API gateways, of ALBs. How can I make sure that my DevOps and developers really configure them correctly and make sure that WAF is enabled for all of these gateways? So the answer for that would be to use a posture management system like CloudGuard Posture Management, and then it allows you to write your own governance rules, so you can make sure that whatever you set is really enforced at scale. So let's see how it looks like. We are now in the posture management, in the GSL builder. We are building some custom rules. So in this case, we took application. We just clicked on application load balancer should have WAF regional. That's our rule. Make sure that an ALB or an API gateway has a WAF regional. I can test it against any of my environments, and I can see that, hey, I've got one faulty web application that does not have any WAF deployed. As you can see, the WAF regional setting and the web ACLs are null. It means nothing is deployed in that environment. So imagine that now this system deployed to hundreds of AWS accounts and scanning thousands of API gateways and ALBs. reporting back to you in the central command, the CISO, or whoever is responsible for security in your company. Okay, now let's take it even one step further. So, as we said, WAF is a kind of a basic tool. We can take that security one notch further using a full-blown workload security. But this time it's a very, very purpose-built workload security, purpose-built for serverless application for Lambda. So at the core of it, there is some kind of a library or a Lambda layer that is injected into your Lambda function, and then it protects the Lambda function from the inside. So it has a lot of visibility into the Lambda function. It can do very advanced security. So first of all, it's a kind of an embedded WAF, but at the core of it, it's a full-blown runtime prevention that analyzes the function behavior and then establishing a true baseline of the function activity. Then it locks it down and applies a minimal privilege runtime profile that includes file access, network access, processes. So it's very, very difficult now to attack the function without it being deviated from its normal behavior. Let's see how it looks. So right now I'm looking at one of my Lambda functions. I'm now asking the system to auto-protect, to instrument the defense, the function self-defense. Of course, it could be done also in the CI/CD phase. In addition, we will switch the block mode, so we prefer to prevent rather than detect. So now the function will block all malicious activities. So we're done with the baselining, and we can see that the local file inclusion attack was automatically detected and blocked by the system. So and again, this is a pretty basic attack, local file inclusion, but that same system can prevent against much more sophisticated attacks. Okay, so far Maya got an access to Lambda functions. Thankfully, it's still a very non-privileged Lambda function. Let's see what she'll do from here.
Okay, so we did now have this Lambda function or a way to actually mimic this Lambda function. But as we'll soon learn, and you'll soon see how, it doesn't really, the role of the Lambda doesn't really have too many permissions. But there is one interesting permission, which is the permission to assume the role, to assume a different role, which means actually acting on behalf of a different role with its permissions. So, but we still don't know which roles are even available. So let's see how we learn more about that. So what I'm going to do is use a pretty cool pen test tool that was developed by our friends at Rhino Security. So let me log in to Paku, that's the name of the tool. And as you can see, I'm logging in well, with my stolen Lambda credentials. Okay. And what we will do now is to run enum permissions to see which kinds of permissions this Lambda or this stolen Lambda actually has. And the answer would be pretty disappointing. We don't really have any permissions here. And so what we'll do now is a really cool trick here. We're moving to using my own account, the hacker account. And here, what I'm going to do is to run enum roles. So now what Paku is doing for me is enumerating over hundreds of different default and commonly used roles within AWS and give me the list of roles that exist in this environment. Now, this activity is super noisy, and that's why I've moved to the hacker account, to my account, when running it, because eventually what it's doing is that it's querying all these different roles, and by the response that it's getting, I can actually understand whether or not this role exists. So it means numerous queries, not something that I would want to run from the target's account. So it's done, and you can see that we have found three different roles available here, and one of them has a very interesting name, EBS snapshot role. So hopefully it means that it has access to EBS. What Paku also tried doing here for me is to try and assume these three different roles, but it failed. And the reason it failed is that, again, I'm logged in now from my own account, the hacker account, which doesn't really have the right permissions. So with this, I will stop with Paku. Thank you, friends. That was super useful. And I will move back to using my stolen Lambda profile, which, as I mentioned, has the option to assume different roles. So now we know the name of the role that I want to assume, which is EBS snapshot role, and I will assume it from the stolen Lambda profile. So in other words, what I'm doing here is plain old classic privilege escalation. I'm taking the stolen Lambda and adding to it the permissions or the role that allows access to, hopefully allows access to the EBS snapshot. So now I'm taking this token that I've created and I'm saving it locally so that I can use it at the next stages of the attack. So now I have this token with the stolen Lambda that has permissions, hopefully to EBS. So with this, in the next stages of the attack, what I'm hoping is to find some EBS snapshots that I can access and try to steal the data somehow without Roy realizing it and stopping me on time. So Roy, back to you. How does it look from your side so far?
Thank you, Maya. So that was pretty sneaky. Maya was able to do some enumeration in my account, was able to expose a misconfigured IAM permission, and then assume into a much more privileged role. So let's see how we can defend against that. So the first thing is preventative, put preventative measures. And in this case, one of the problems here was that the original Lambda function had an IAM permission that was way too permissive. In this case, you can see here on the screen that we have STS assume role asterisk and then S3 asterisk for all resources. So that's way overly permissive policies. So I do not expect you to now log in to every account, every IAM role, every policy in your environment and start to look for those anti-patterns. But still, it is possible to write a pretty simple script that will do this enumeration and at least tell you that you know the most kind of common anti-patterns are happening in your environment. So again, STS assume role asterisk, S3 asterisk, and many other like that. So with that, you'll only be able to detect the low-hanging stuff, but still, I'm sure you'll find a lot of stuff. If you want to take the least privilege, the minimal permissions approach to the next level, then you can use more tailor-created automation. So for that, there is the Cloud Guard that can also automate your IAM policies. So for that, it's actually pretty deep technology that scans the Lambda function code, understands the live code paths that at the end of the day call an AWS API, and then matches it against the actual IAM policy of that specific workload. So it then allows you, it shows you what kind of overly permissive permissions are configured and even recommends you the minimal permission to do so. So let's see that in action. We'll switch now to the IAM policy and I can see the suggested fix again, a least privilege policy tail build for my exact Lambda function. And I can see those two overly permissive, the S3 and the STS assume role permissions that the system has automatically highlighted them for me. So the last part here is a detective measure. And here we're going to use CloudTrail, which was launched in 2013. And in my opinion, it's probably one of the most important security services that AWS has provided us. And it, for those of you who are not familiar with that, it provides us an audit trail of all the API activities happening in the cloud control plane. So there are multiple ways to reason about it. In this case, I'm writing a SQL statement using Athena. And I'm focusing here on the error code that is access denied, and the event name is assume role. So this really helps me in order to find all those people sneaking into my environment, trying to assume into different roles, and leaving a lot of breadcrumbs. However, that approach might be a little bit, it might yield a lot of false positive, because it could be that a legitimate user will try maybe to assume into the wrong role, or maybe some DevOps script that is doing that. But after some fine-tuning, I'm pretty sure that you'll be able to kind of fine-tune it to your own use cases. And again, I used Athena here. We could use CloudWatch logs, or we can pipe it into a SIEM system and do this kind of alerting and queries over there. Or, of course, pipe it into a cloud-native security system that was designed from the get-go in order to create value on top of those data feeds. So let's take a look at that in the CloudGuard logic, the Cloud IDS. And let's switch to the alerts pane, and we can see this alert by logic, abuse of access token. So again, this is not a generic access was denied for some role or something like that. The system is actually able to understand the exact lambda that was compromised. And in this case, we see the name is vulnerable lambda. And the way that the system is doing that is a pretty sophisticated security analytics. So the system is able to understand that, hey, this is a lambda that created a session token. And now we're seeing that same session token being used by a completely different entity. In this case, this was Maya machine operating from somewhere on her laptop, completely disconnected from the AWS Lambda environment. So by doing all these correlations, the system is able to provide us this high fidelity alert that our Lambda was, that the Lambda's access token were abused by Maya. So Maya was able to leverage herself into a more privileged role. Let's see what she can do with it. Let's see if she can do something to my data.
Okay. So everyone, these are the last couple of miles of the attack. I promise. It's going to be very short. So now I have the access to a token that can access EBS. But I still don't know which EBS snapshots are available to me in this environment. Thank you. So now what I'm going to do is actually to run another AWS CLI tool to enumerate over all the EBS snapshots that I have access to. And you can see that there's a handful of snapshots available, but one of them actually has a pretty interesting name. It's called Mongo Backup 2020. So looks like a bingo. This is probably where Roy saves all of his secret data. So now how do I copy the information from there, or how do I access it without making too much noise? I could try to abuse some machine to access or to fetch the snapshot, or I could just copy it to some S3 bucket, but these activities again would be too noisy and just might trigger some security measures that Roy has. So what I will do, and again that's a pretty cool thing I can do here, is through this stolen Lambda profile, I can actually give myself or the hacker profile access permissions to the EBS snapshot. So this is exactly what I'm doing now. I'm giving myself the access, and then when I access it from my account, it will not create any noise in Roy's account. So you can see that I now have this access, and what I will do is go back to my own account and actually save a volume of this snapshot. I've created the volume, and now I'm attaching it to my own EC2. And when it's there, this is actually the final part of the attack, because now, even if Roy realizes that I've breached his environment and removes my permissions, it no longer matters. I have all the information under my possession, and I can now start looking at it, finding the interesting data, and use this forever. So mission complete here. So to conclude the attack flow, you can see that just by exploiting some pretty common configurations and programming mistakes, I was able to access Roy's crown jewels without him really noticing it, and with it flying under the radar of his traditional security measures. So I'm sorry about that, Roy, but would you please tell us what we've learned from that and how you can do better next time?
Thank you, Maya. That was pretty sneaky. Even though I had all sorts of network security analytics tool, Maya was able to leverage the APIs, some APIs of the cloud, APIs of the backup, and then modify the permissions and exfiltrate the data not through my network or my EC2 instances that are under my control. So let's see how we can detect that. So the first thing is the fact that Maya has modified the EBS snapshot parameters and made them public, or in this case, she only exposed it to her own account. So modify snapshot attribute is our friend here. This is the action that started this entire flow. So this is something we should definitely look out in our SIEM system, in our security analytics tools. And from internal tests that we did at Checkpoint, we saw that it's pretty non-common practice to do this. It could happen when you have maybe a remote DR site and you're sharing something with it. But for most of the accounts that we witnessed, it's not happening. So this is a very, very good attribute to search for. The second option, which now this is actually a little bit too late, is the actual moment where Maya is able to take the snapshot and then create an actual volume out of it. So this is a pretty unique event called shared snapshot volume created. And what's unique about it is that this is an event that happened in the attacker account. But still, thankfully, the EBS team has provided us some breadcrumbs in our own account. And even though this entire action happened in my account, still I get some kind of notification, shared snapshot volume created, telling me that my snapshot was being used by another account. So again, this is a great event to look at, even though it's a little bit too late by now. So of course, from in CloudGuard, you'll get that automatically taken care of you or alerted for you. And as you can see, the system automatically sees that and alerts you that there is some EBS volume share to another account. So again, you got that fully configured from the get-go. Now, if you click on the Investigate tab, by the way, it's we can further the investigation. And we can see that this weird AWS account 9133 is connecting to my environment. In this case, it's cloning the snapshot. So again, we are not expecting this weird AWS account to connect to our environment and create volumes out of this snapshot. So we got it. The last control that we'll discuss is preventative measures. And as I said, sometimes it is really requested or required to do these sharing of EBS between accounts. So, but still, this is a very rare operation, right? When we are coming from a backup or testing a DR site. So imagine that you could take all those very dangerous action or rare actions or actions that have deep security implications and reduce these permissions, take out these permissions from all your users and role, and only just in time enable them. So that's exactly what the IAM safety does. You define your dangerous actions and only just in time using a mobile phone app or the web, you can elevate a specific individual or a specific role and let them do their job, which in this case it's very non-common. So let's understand what happened so far. We can see that our adversaries, and Maya in this case, they're not standing still. They are sharpened and learning new skills. We too need to cloud nativize our processes and then our tooling in order to cope with these guys. And another takeaway is that AWS provides us a really great starting point, a lot of security services. But however, we must make sure we learn them. We must make sure we properly configure them, and we must make sure that we properly utilize them and operationalize them. And of course, third-party tools can give you a good head start with great out-of-the-box experience, but only if we're designed for the cloud from the get-go. So, next step for all of you, learn, right? So AWS has tons of security-related documentation. Actually, don't get too intimidated by it. There's a lot of content. So go to those links and learn and understand, start to plan your learning path. And in addition, if you'd like to give CloudGuard, the Cloud Native Security, a test drive, feel free to check the Checkpoint website and give it a test drive. So thank you. Thank you for my adversary, Maya, that taught me some new tricks. And also special thanks to Dror Alon from Checkpoint Cloud Research and Hillel Solo from the Cloud CTO team that helped us create this content. Thank you all very much.